So let's take one of our most well-known of all chemical reactions. It's the subject of so many discussions and exemplars and textbooks. The creation or dissociation of ammonia. In this case, we're going to have ammonia break up into nitrogen and hydrogen, so we can assume entropy will increase in this case. So if we were doing the standard thing of looking at, based on our tables, the standard tables, what's going to happen if we try to make this reaction happen at 25 degrees Celsius or 290 K by using the standard values of formation for enthalpy and the standard entropies, we are going to find, if we look up in our textbooks here, I just drew this from the text, and we put our change in Gibbs equals change in enthalpy minus our 298K times the standard entropy set into kilojoules. We'll find that this is very much a not spontaneous reaction. It will not happen normally under these particular conditions. This would be the minimum threshold of energy that we would have to add artificially into that chemical system to make it happen. Maybe it's electrical energy or something that would be required to make this happen. So maybe somebody who's wanting to make this reaction says, well, okay, what can we do to not have to require all this energy to bring it into spontaneity? Well, maybe we can raise the temperature of the system, which of course requires energy too, but at any rate, for whatever reason, maybe that's the option we're looking for. So above what temperature would this reaction become spontaneous? This is where we just simply set delta Gibbs to 0 to solve algebraically for temperature as an unknown. Okay, so this is basically the classic algebra 1, set one side to 0 thing. And so that's what we do here. We just simply take the change in enthalpy divided by the entropy, and we find 1,106 degrees Kelvin is the threshold point. This would add, and because this is Gibbs at 0, this is basically a kind of an equilibrium point that neither favors products nor reactants. Okay? But above this temperature, once we get above this temperature, we start favoring products. We start favoring the production of nitrogen and hydrogen. If we go below this temperature, we start shifting the reaction towards favoring the reactant, which in this case is ammonia. So higher temperatures will shift the reaction to this, lower temperatures will shift the reaction that way.